First of all, thank you for taking time out of your busy, probably short week for many of you to join us and just learn about Kubernetes security and where it is today. I'm joined here by Andrew Akers. Andrew, do you want to go ahead and introduce yourself?
Hi, thanks, Cal. Hi, everyone. Thanks for joining. I appreciate it. My name is Andrew Akers. I'm a senior product marketing manager at Aqua Security. So I oversee a few things, but what we'll be talking about today is Kubernetes security.
Awesome. And for me, I'm Kyle McNulty. I'm a senior manager in Focal Point's, now part of CDW's cyber defense practice, and I head up all things cloud security and DevSecOps. So obviously Kubernetes and Kubernetes security is very near and dear to my heart here. As far as timeline for this presentation, we're shooting for roughly 45 minutes or so, followed by 15 minutes of Q&A, but we'll see how that all goes. And one way or another, you'll certainly have an opportunity to ask us questions offline if we don't get to answer your question during the webinar. And Andrew and I's contact information will be available at the end of the presentation. You're welcome to take that down and follow us on any social media and ask your questions publicly or privately, whichever you prefer. And then finally, want to just go ahead and introduce each of our companies briefly for those who might not be familiar with Focal Point or Aqua. So I get to read the fun boilerplate blurb. I'll try to race through it as fast as possible. Focal Point is a leading cybersecurity services provider working with companies as big as the Fortune 500, as well as government agencies. We integrate market-leading consulting, technology integration, and cyber workforce development services to provide end-to-end solutions for security leaders looking to future-proof their companies against threats, changing data protection laws, and growing workforce shortages. Again, like I mentioned, we are now part of the broader CDW ecosystem as well. So all sorts of exciting new opportunities for us and our team looking ahead, and more resources that are available to our clients as well. Now, as far as Aqua is the largest pure play cloud native security company, in large part coining the term CNAPP, which you might have heard more recently, providing customers the freedom to innovate and accelerate their digital transformations. The Aqua platform provides prevention, detection, and response automation across the entire application lifecycle to secure the build, secure cloud infrastructure, and secure running workloads wherever they are deployed. So again, appreciate you all bearing with me on that. Hopefully you have a bit better understanding of what each of our firms are doing. And with that, let's go ahead and dive into the presentation here. All right, so hopefully that's pulling up for everyone in the next few seconds here. Again, the topic today is about Kubernetes security. What sort of problems exist with Kubernetes? What are some key attack scenarios, along with different controls that you can actually go ahead and apply to help secure your Kubernetes environment by the time you walk away from this presentation today. So with that, we always have to do the fun kind of context setting conversation as far as where security fits in today. I promise I'll keep this piece short as well. I'm sure many folks on the phone here today understand the relationship of security within the broader DevOps environment. The ultimate takeaway as we think about this is, how does security play with both the build, infrastructure, and workload components? More and more developers are looking for flexible ways to deploy their applications. They're looking for modern technology stacks, and they're looking for more ability to kind of autonomously manage that, which means that security, when acted on in kind of the traditional mechanisms, is viewed more and more as a roadblock. And so ultimately the chief concern of security for a modern organization is, how do we still ensure that we're enforcing the necessary controls and preventing the risk, again, required for our organization without inhibiting these different developers' actions and preferred workflows. So with that comes the cloud native stack and everything that exists within the cloud today. So if you look through each of these different logos that's listed here, no, I'm just kidding. But ultimately, the key piece to take away from this is really the trends and kind of overlaying categories of the cloud native stack, right? So we have application, orchestration, container runtime, and cloud infrastructure. And again, the key piece of this is that all of these are interrelated with one another. Exposure at any one of these layers can lead to compromise at the others. And so security can't take it easy on any of these specific layers. And obviously, when we think about Kubernetes and orchestration, that's a potential weakness and vulnerability into the rest of the stack. And when you think about the extensive efforts that are being made either on the infrastructure layer or at the application layer with like SAST, DAST, IAST, etc., all these advanced testing mechanisms, it's important to have the same sort of maturity and security presence of mind in the orchestration layer with Kubernetes. And so again, that's what we're going to be drilling into as we go further in this presentation today. So is Kubernetes secure? I'm sure everyone has an idea, but Andrew?
Thanks, Cal. I'm going to take over for the next few slides here. So, the name of this presentation isn't cloud native security, it's Kubernetes security, right? So we talk about the whole stack because you can't talk about one layer without talking about all of them, but we want to kind of simplify it down so that we can focus on this layer here, specifically the orchestration layer, and even more specifically Kubernetes. So what I'm going to do is I'm going to walk through 3 attack scenarios. So we want to answer this question: is Kubernetes secure? The short answer is it can be. It's often not. So let's walk through some of these attack scenarios so that you can understand. So the first attack scenario is a vulnerable application. So in this case, where the attacker is actually attacking a different layer first. So this is why it's important to understand how all of these different parts of the stack interact with each other. So in this case, the attacker gains access initially through a vulnerable application and then deploying a vulnerable container image. So let's just say, for hypothetical sake, he has some kind of vulnerability within the application that allows for remote code execution. The attacker is then able to execute that code, escape, and then deploy a malicious image themselves. If the pod has a full host path mount to the entire file system of the underlying host, they can then escalate their privileges and steal the admin pod secret from the file system. So this is just one scenario that leads to once they have all of that, the impact is they can continue stealing resources. They can run more containers. They can drop crypto miners. They can steal data and drop other malicious files. So that's one example of where the orchestration layer itself may be hardened, but the application is vulnerable, and it leads to this compromise. Let's go to the next slide. Let's talk about a malicious container image. Similar to what I said before, except the entry point is not a vulnerable application. The entry point is a compromised image in a registry. So whether your company uses their own private registry and somebody has compromised that and compromised one of the images in the private registry to contain malicious code, or they've compromised an image on a public registry such as Docker Hub. There is an example. This isn't Docker Hub or container images, but recently somebody took over the credentials of a popular npm package and inserted malicious code in it. It was only live for about 4 hours or so, but the name slips my mind off the top of my head, but it had a wide reach. So that's essentially a supply chain attack. We're talking about essentially the same thing, except with container registries here. The other way that people will do this is they will take a malicious image and they will typo squat. So they will name it something very similar, but maybe 1 or 2 letters off of a popular container image, and then hope that a developer typos when they pull the image and pulls down the malicious one and never realizes it. So once they have deployed this malicious image, it could be deployed in a privileged environment, giving the attacker those privileges as well. There are also plenty of other forms of privilege escalation and container escape. Really, the attacker is looking to escalate their privileges and move laterally so that, again, they can steal resources, drop crypto miners, steal data, and sensitive information. So let's move on to the next one.
Yeah, and one thing I do want to just highlight really quickly, right, is within each of these different attack scenarios that's been posed so far, there are these different steps that fall within the attack itself, right? And each of these different steps is an opportunity for detection, prevention, and ultimately mitigation of the attack. And again, we'll talk more about this towards the back half of this presentation as far as what some of these different mechanisms are. But one of the trends that you can hopefully see already is running a container as privileged provides this much easier opportunity for privilege escalation that's going to lead to more severe impact for the attack. And so again, if you're thinking about, all right, well, how can I reduce the risk of these negative impacts as much as possible with the least number of actions, you can already see, okay, if privilege escalation is a trend across these different attack scenarios, that's one simple way that we can go ahead and modify that risk profile. So just something to keep in mind as we continue to walk through these and think through some of the different control opportunities.
You're exactly right, Kyle. And then, so because this is a Kubernetes webinar, I want to spend some time talking about Kubernetes misconfigurations. So on the screen here, we have one example, and that's an exposed dashboard, that allows people to access it on without authenticating. But a few other ones here is you're running your kubelet anonymous authentication by default. That could be misconfigured to be public facing. So this is similar thing to what I just mentioned. Mistakenly binding admin roles to the system unauthenticated group for RBAC, essentially allowing people who are unauthenticated to access the system through, by not forbidding them through the RBAC, the role-based access control policies. Like we mentioned earlier with running containers privilege, running pods as root is a risky misconfiguration that can lead to container escape and running root on the underlying VM. And then finally failing to set the audit policy file flag with basic metadata and pod change logging. So this is important for properly logging events within Kubernetes so that you have something to investigate if something ever happens. So no matter what the entry point is, any of these misconfigurations can either lead to an attacker entering the system or lead to them hiding within the system, such as the case with the logging there. From there, they can deploy a privileged container, perform some other type of privilege escalation, and again, steal data, mine cryptocurrency, drop other malicious software. We see, in this example, we talk about communicating with the command and control server. We've seen recently a uptick in attacks that have been cryptojacking attacks, but that leave backdoors to maintain persistence. So these attackers are able to continually access the environment while their malicious software is mining cryptocurrency. So the impact doesn't necessarily stop at stealing resources and mining cryptocurrency. They can still steal other stuff, expand to other areas, other clusters, move laterally, and continue to steal those resources.
Yeah, and so just again, one more thing here, thinking back on some of those different specific misconfigurations that Andrew mentioned, right? Either the system unauthenticated group or anonymous auth by default and exposing it to a public IP, failing to enable audit logging. All these different examples, you could see potential developers within your organization making these changes just from a convenience standpoint, right? Maybe they want to go ahead and ensure that they don't have to log into the VPN in order to access their Kubernetes cluster, right? And so they just assign it a public IP, and anonymous auth, again, is set by default. And so all of a sudden, anyone can go ahead and have access to this, right? Maybe they want to make sure that within their pod, they have access to all the different resources that they need. And so they just run it as root. And again, these are kind of the lowest level of effort options for the developers in some scenarios. And so this is where it's important to understand, okay, what sort of policies do we have around our Kubernetes configurations, and how are we ensuring that the proper training and learning exists within the organization so developers will put in that extra maybe 5% effort and make sure that it's secure rather than blatantly insecure. So again, just keep in mind that it's very, I guess, realistic and rational that developers might go through some of these different insecure options if they just don't have the awareness as far as what is insecure. All right.
Exactly right. So what do we do about it? How do we secure Kubernetes? So there's a really good book that I read called Hacking Kubernetes. It's an O'Reilly book. It gives you a really strong kind of understanding of where things can go wrong with Kubernetes. And I'm gonna read this quote and then I'm gonna modify it a little bit. But as with all fast-moving software, there have been vulnerabilities in most parts of the Kubernetes stack. The only solution to running modern software is a healthy, continuous integration infrastructure capable of promptly redeploying vulnerable clusters upon a vulnerability announcement. So what Andrew Martin is saying here, and Michael Hausenblas, who are the two authors of the book, essentially is that when a vulnerability announcement comes out for any part of your stack, you need to have a system in place to kind of redeploy, patch it, make it less vulnerable. I'm going to modify it and saying that it's not the only way is redeploying vulnerable clusters, but the concept of there's an incident or a vulnerability announcement, and you must respond either by redeploying with a patch system or inserting some other security control in place of that to ensure that an attack isn't able to take advantage of a vulnerability or to extend past an incident. Next slide, please. Yes. So we must kind of evolve application security to meet cloud native security. So I like to think of this in terms of, if we want to use an analogy, think about a building and securing a building. You need visibility. So if you think about security cameras, kind of constantly monitoring an entire building, continuously scanning it, looking for people breaking in or any kind of thing that's off. But security cameras themselves can't really do anything. So in our analogy here, visibility means continuous scanning to find misconfigurations, exposure of sensitive data and secrets, signs of malware and vulnerabilities at the orchestration layer, but also, you want that in other layers as well. Now we need control. So if we go back to our analogy, security cameras can't do anything but see. You still need your security guard to go out and actually respond to an incident. So if security cameras identify an incident, somebody in the building that shouldn't be in there, the security guard needs to go out there and confront them. So that's where we need control. So control is both preventative measures, so that's locking the front door, and then also response measures, so responding to an incident. So we want to prevent, in this case, a couple of examples. We want to prevent direct access to the cluster. This in turn, we want to prevent the creation of bad resources. A lot of times you'll see attackers through some entry point get into the cluster, and then they start pulling down malicious images. They start running vanilla images with bad commands. They create these resources that are quote unquote bad. Next slide, please. So to talk about visibility a second before we get to control, visibility means something a little bit different when we're talking about cloud native than if you are thinking in terms of kind of your traditional IT infrastructure. In the past, the network visibility essentially meant things like packet capture, monitoring metadata like net flow, logging things off your firewall and other infrastructure devices. That's all well and good for an IT infrastructure, but networking in a cloud native environment is based on service identity, and resources are ephemeral, which means you can't rely as heavily on IP addresses and other aspects that traditional network monitoring would rely on. So you need that real-time visibility into namespaces, deployments, nodes, containers, and the images they came from, as well as network connections between and within namespaces. So you want to essentially make sure that your visibility is contextual to cloud native and your environment, and you want to make sure that there's no blind spots. Those are the big things here. And then if you want to go to the next slide, please. I'm going to walk through a few examples here of just kind of where you can get in trouble and how visibility and control can help. So here in this example is I want to talk about a Kubernetes service that can be essentially exploited for an attack. And I'm going to talk about a specific CVE. I'm not going to read it out loud. Y'all can all read it on the screen. That is in, I forget which versions of Kubernetes, but it essentially allows, it's an internal service with an external IP address that allows an attacker to gain direct access to the system. And from there, they can do a whole host of activities, one of which is circumventing admission controllers. Now, if you're not super familiar with Kubernetes or what admission controllers are, many security solutions operate as admission controllers. Basically, when you want to deploy something, you have an admission controller that uses some logic, whether it's scanning the images, looking for vulnerabilities, etc. And it either mutates it and changes it before it deploys it, or denies it and say, we don't deploy this, right? So it's a security control, and circumventing that security control has a huge impact for an attack. Next slide, please. So the next thing that we want to talk about is exposure, exposing sensitive data, right? Kubernetes has an object called secrets. You want to store secrets in that object. It's best practice. Sometimes developers, can get in trouble storing secrets elsewhere. A common thing that we see is storing sensitive data like credentials and other things within config maps. Unfortunately, this introduces risk. A lot more people have access to what is inside config maps than necessarily the secrets object. So you want to be able to detect when there's sensitive data inside config maps, whether that's credentials, even PII, such as credit card info or social security numbers. Just you want to be scanning config maps as well as other resources for evidence of sensitive data so that it's not exposed.
Perfect. All right, so the next piece to talk about, and we already started talking about this as far as permissions, right? But it's just applying the same kind of role-based access control that you'd apply for your cloud service provider to Kubernetes itself, right? And within that, regularly scanning to identify any misconfigurations that might exist. So again, folks are probably familiar with what that looks like at this point. Maybe you have all admin, no restrictions whatsoever, and it's worth that kind of extra investigation to understand who has access to this role, what sort of activities are they able to perform, is there a legitimate business justification for this role, and how can we potentially scope that down or use like dynamic access provisioning so they only have that sort of access when performing administrative functions instead of having that role standing and available for attackers to potentially compromise.
Kyle, if you don't mind, I want to jump in real quick on that last slide and just add one thing here. When Kyle says regularly scanning for kind of misconfigurations and overly permissive access, I just want to underscore that point. What tends to happen with role-based access control and RBAC policies is that they have kind of an entropy of sorts, and over time, they often become less restrictive. And the way it works is somebody needs access to a resource they don't have access to. They ask for permission. And then after they use that resource, they don't go back and say, you should revoke my permission. It's very unlikely for people to go in and actually volunteer to have their permissions revoked. So over time, these kind of RBAC policies become less effective. So you want to be able to continually monitor them to assess the risk there. And that's it. I just wanted to underscore that point.
Yeah, no, it's a good point. And even building on that, right? When you think about adding a new individual to your organization, how are you going to assess what role is necessary for that individual? Where you're going to look at other individuals in the organization who are performing similar responsibilities, and you'll likely assign them the same role across all the different systems that you're using, right? And so to Andrew's point, once you have that kind of expanding RBAC role, then new individuals are getting added to that as well. And you have this growing set of access capabilities along with a growing set of individuals who are provisioned that access. And so it's kind of compounding in both those different directions. All right, so the next piece, we already started talking about visibility a little bit, right? But I'm sure for any security professional on the phone here, it's very relatable in terms of the difficulty of actually using the data that's being generated by your different systems. So just simply collecting the logs and sending them all to a single location isn't going to be enough if you don't have the appropriate for example, dashboards that are giving you visibility into the events that are actually worth investigating, or alerts that are notifying you when it's critical security activity that actually needs to be investigated further. And again, one of the pieces that we talked about just kind of offhand earlier was the lack of audit logging within Kubernetes to begin with. But certainly when you turn on audit logging in line with CIS benchmark best practices, then you're creating this whole new host of data that's going to be collected for your cluster. And it's then important to understand, okay, what are we monitoring for within this, rather than just saying, okay, we're logging and monitoring Kubernetes data, problem solved. The question is, well, how are you actually making that data usable and making sure that the appropriate individuals within your organization can actually act upon that data, again, as opposed to just collecting it. The next piece of this is really how controls have to be cloud native, right? And so moving beyond this kind of visibility component, there's all sorts of different third-party platforms that exist today, but how are those looped back into the cloud native controls themselves, the different activities and potential resources that exist within your cloud environment? And beyond that, right, when we talk about DevOps and DevSecOps, one of the key principles of DevOps is this idea of automation, empowering developers and operations teams to leverage automation, but then security must adapt to that as well and develop automated processes to actually go ahead and manage the security risk that's being identified, so developers don't have to go through and do that manually and take valuable time out of their days. And so again, that's one of the things you have to think about is once you have these different issues identified, you have that visibility, how are you making sure that it's actually being remediated in a feasible manner for your organization? Because if you have the visibility and you aren't actually remediating against those misconfigurations that are being identified, then you're not actually improving your risk posture of your organization. So again, I mentioned that we'd come back to the CIS benchmarks. These are helpful across all of your different technology systems. Our team uses them for all sorts of cloud security work that we do, whether it's any of the CSPs, the cloud service providers, but it also pertains to Kubernetes as well. Like I mentioned, right, there's a whole set of best practices that exist to make sure that your organization is protected against those common misconfigurations. One of those, like I mentioned earlier, was that enabling audit logging. CIS benchmarks can help ensure that you're implementing those appropriate practices. And as we can see here, a screenshot from the Aqua tool, it's a easier way to understand where your organization is compliant and where there's opportunities to further improve and harden these clusters. So the next piece is around the actual image enforcement. So ultimately, how are you making sure, I think, yeah, there's one more. How are you making sure that the images that are actually in use within your organization are secured beyond just kind of the Kubernetes layer itself, right? And we already talked about this earlier on as far as setting the stage between these different layers, how they all interact with one another, but how are you ensuring, again, from the control standpoint, that vulnerable images aren't actually in use within your organization? So we can see here that this Nginx 1.7.1 is specifically marked as non-compliant. We have 25 critical vulnerabilities, certainly not something that we want lying out within the organization. And so developing policies to ensure that your registry isn't approving the release of these different container images unless they're meeting different security thresholds. And again, this goes back to a kind of broader challenge that you have to deal with as security representatives in terms of developers might insist that Nginx 1.7.1 is the only image that actually supports the current version of the application just based on different dependencies that might exist. So how can your security team then work with that development team and say, well, what are the compensating controls that we can put in place to make sure that the application can still run as it needs to for our business processes, but we're addressing at least the most severe risks that come out of it. And so again, you can have that automation piece to make sure that only approved container images are actually slated for deployment. And then also the just partnership piece with your different developers in your organization to make sure that if there are exceptions that are necessary, you're building the appropriate compensating controls in place to account for it. And again, this touches back on what we were just talking about. Rather than the container images themselves, though, what's the different configuration that comes along with a resource that might be inherently insecure? So this might be a misconfiguration that's typically controlled after the fact. So a resource is created with public-facing IP address, then Aqua or whatever scanning tool you're using identifies that misconfiguration, and someone has to go through and actually remediate that misconfiguration. But instead, we can actually apply prevention policies to ensure that that resource isn't created to begin with, right? So you can see here, you even have the specific rule that's informing the user of the mistake that was made, so they can go forward and actually change that configuration, make sure that they're still deploying their resource as they need to, but without that insecure aspect that would otherwise need to be resolved at a later point in time. Now, even the next piece here is thinking about runtime. So we've talked about the container image, we've talked about configuring different services and different resources within Kubernetes, but then there's actually the runtime component as well, where a container might be compromised, attackers might be trying to execute known malicious activities. And this is again where Aqua has the capability to detect these different runtime mechanisms and block them before the attacker is actually able to execute these different processes. So if kind of all else fails, you think about that last line of defense, at least there's still a tool there in front of you that can help prevent those common mechanisms like the cryptocurrency miners that we talked about in these different attack scenarios earlier. So Andrew.
Thanks, Kyle. So at Aqua, we aim to be the most comprehensive and integrated cloud native application protection platform out there. So today we just talked about Kubernetes and our as far as the product offering, the KSPM, or Kubernetes Security Posture Management. This is how we secure the orchestrator, but we also, like we mentioned earlier, you got to think about the rest of the stack. So we have at Aqua, we have products there too. We have products we just completed an acquisition. We've done all kinds, we have products for vulnerability scanning at the container level. We have CSPM products, et cetera, et cetera. We have all kinds of things that work together and are part of the same platform. They're not just integrated, they're part of the same platform to deliver results. As far as KSPM goes, the main things that we want to, stress that it provides is, one is that visibility across clusters. It's a Kubernetes native approach, right? Just like you want your security to be cloud native in a cloud native environment, you want it built for Kubernetes. Risk assessment and compliance. This big thing is identifying risk, both, things that are, violate kind of CIS benchmarks, so that compliance element, but also just in general, risky misconfigurations, risky activity. We want to be able to identify that information and respond to it. And then last, but certainly not least, is automated policy enforcement. We extend Kubernetes native capabilities. We enforce policy-driven secure configuration and governance, and then we automatically segment workloads. So we bring all of this together to secure Kubernetes. But like I said, think about the rest of the stack as well.
Yeah, that's an important piece I wanted to just highlight a little bit further, right? As more and more in the security industry today, we see this kind of disjointed tool set across an organization. You might have 25 or 30 different security tools that are all handling their kind of individual responsibilities as a part of your security posture. Obviously, we have a Kubernetes native security approach that's being talked about here, but because that fits into a broader cloud security platform, you don't have to worry about having 6 or 7 different cloud security tools that are all focused on each of these different components and need to be integrated back through API calls or anything like that. You have single pane of glass dashboards that provide that visibility that we talked about, and the automated control pieces that Andrew just referenced as well, again, all within this platform. So Kubernetes security can then just be a component of your broader cloud security, as opposed to another tool that needs to be integrated, procured, and all that good stuff. So with that, again, as far as focal point and everything that we do, there's 3 kind of key ways that we can help your organization. The first is managed services as we think about Aqua. So again, if Aqua is an interesting tool that you're just learning about in this conversation, then we can certainly help ensure that you're actually implementing and managing that tool effectively within your organization and environment, understanding the different challenges that are specific to your cloud footprint. What are the different resources that need additional protection? How are you managing your registries? How is Kubernetes leveraged and managed within your environment? And then actually tuning Aqua to remediate the different false positives that might exist and the different business justifications that we talked about, again, where developers might need specific exceptions in place to manage their work. The second piece would be around secure cloud environment construction. So we understand that more and more, and this trend has been going for a long time now, but more and more organizations are moving to the cloud and they need secure cloud environments. Maybe you have developers that have been running rampant in the cloud for a couple of years, and now the security team is just starting to realize the amount of kind of shadow cloud IT that exists within your organization and is trying to play catch up. Well, we can help provide those baseline security mechanisms, make sure that everything that's operating within that cloud environment is secured according to best practices. Even if you're planning one of these migrations and need a new environment that you can kind of lift and shift into, again, we can help secure those environments with the appropriate security guardrails that set your organization up for success. And then finally, the cloud security assessment. So if you're just unsure kind of where you stand from a cloud security standpoint, or are looking for a more cohesive strategy and roadmap moving forward, if you want to kind of experiment with some of these different cloud security best practice tools that exist today, like Aqua, and want the ability to, again, kind of understand what that looks like, we use these tools during our assessment to provide both the strategy components as well as the technical misconfiguration components and help with the remediation, again, both on the strategy initiatives as well as the direct technical opportunities that exist within your environment. So again, if anything that Andrew and I have talked about today is interesting to you, feel free to shoot us emails and follow us on any social media. We'll be more than happy to go ahead and answer any follow-up questions and set up specific conversations to talk about your environments and all the specific challenges that you deal with. So again, thank you everyone for your time today. We mentioned the recording will be shared as well, but we'll have a few minutes for questions at this point. Okay, we had one come in. How much of this risk is relevant to managed deployments like in AWS? So it's a fair question, right? Ultimately, more and more organizations are looking to deploy, again, cloud native, like we talked about. AWS, all the major cloud service providers have kind of custom wrapped Kubernetes services in there as well, which means that ultimately your organization and the security and development representatives within your organization have to do less kind of manual management and configuration of your Kubernetes environment. And ultimately, that's going to provide you an additional level of security, right? Like we mentioned, there's these different kind of opportunities for misconfiguration that exist, but the less your organization has to manage, and the less you have developers kind of trying to take shortcuts with the management of the Kubernetes cluster, the more secure it's going to be. So by no means does it reduce all of your kind of Kubernetes risk, but absolutely helps reduce the potential for introducing additional vulnerabilities and misconfigurations. Good question.
I'll take the next one. So the question is, given the security risk, should we be encouraging our developers to use other orchestration platforms? So the answer is, in general, people pick orchestration platforms based on their development needs. Kubernetes is highly configurable, just like and just like almost every cloud native kind of piece of technology out there. And that highly configurability is a big reason why organizations choose Kubernetes. So what I would say is, of course, you don't want to use an orchestration tool that's wildly insecure. That said, that's not Kubernetes. Kubernetes, like most cloud things, gives you enough kind of or enough room to shoot yourself in the foot if you make a mistake. But with the right controls in place, with the right policies, you can make it, as safe as any other piece of your technology stack.
Yeah, spot on. Okay. Well, if there's no more questions, then again, you should all have our email addresses at this point. Again, feel free to reach out with any sort of questions that you might have. More than happy to field those and continue this dialogue. But again, really appreciate everyone spending some time with us and learning a bit about this topic. So again, encourage you all to reach out and have a great rest of your day.
Thanks, everyone.